Okay, so today we're going to be talking about classifying polygons. And a polygon is a closed figure on a plane and it has three or more segments called sides. And these are joined at vertices. And here's some examples of some polygons on the left and some non-examples on the right. No curved shapes. Um, and we can name them. First of all, the name we can give them would be by how many sides they have. So if you count the number of sides, you can say, hey, it has three sides, it's a triangle. Hey, it has four sides, it's a quadrilateral. It has seven sides. Ooh, that's a heptagon. And then if the length of the sides matches, then it would be regular. Okay, so this is like a regular pentagon because not only does it have five sides, but all five sides are equal measure. This would be considered a pentagon, but not regular because not all the sides match in length. Okay, so um, this is going to be a hexagon here, and this is also a hexagon, but it's not regular because not all the sides match and not all the angles match. So eventually, when you get so many sides, you don't have names for them. And so you can say, hey, this right here, if it had like the number of sides is n, and say like 50, you could call it a 50gon. So you put the number of sides followed by the word gon. And so that's an option. Okay, now we also can classify polygons by their special features. So if your polygon has all the sides equal in length, we could call it an equilateral polygon. So this one here has every side equal in measure, so it'd be an equilateral. Lateral means side. And so if every side is congruent, it would be an equilateral triangle or pentagon or whatever shape you're talking about. So this again would be equilateral because all the sides match. Equal angular means that all the angles of the figure are going to be equal. And so this would be an equal angular. And as you can tell, just because the angles match doesn't mean that the sides match. So on these bigger figures, so equal angles throughout the figure is equal angular. Now, if it happens to have both equal angles and equal sides, then we would say it's a regular. And so a regular polygon is a polygon where not only do the sides match, but the angle measures match. Okay, and so we could have a regular pentagon or hexagon or whatever it is. And so if every angle and every side matches each other. With triangles, they're more special. And because they have fewer sides and fewer angles, they just have three of each, we have some more special names and they have more special relationships as well. So if you've got an acute triangle, well, that means that all the angles in this triangle are smaller than 90 degrees. Smaller than 90 degrees, so that would be an acute triangle. An obtuse triangle has one side, one angle that's bigger than 90 degrees. Okay, can't have more than one, it just has just one of them. Okay, so there's not mathematically possible for it to have more than one obtuse angle within a shape, within a triangle. An equal angular triangle says all three angles are equal. Well, I'll give you a hint. Also, if all three angles are congruent, all three sides will be congruent as well in a triangle. In other shapes, like the ones above here, just because the angles match doesn't mean that the sides match as well, does it? Okay, so it can mean it up there, but in a triangle, if the angles are the same, so will the sides be. A right triangle has one right angle in it, and so we will call it a right triangle if one of the angles is right. So we can give triangles names based on their angles. We can also give them names based on the number of sides. So if a triangle has three different sides of three different lengths, we call it scalene. Okay, none of the sides are congruent to each other. If at least two of the sides are congruent, we call it isosceles. And so that could be this, or technically, if all three sides match, that could also be called isosceles. Honestly, a better name for it is equilateral, but isosceles, I guess, is at least two sides being congruent. So equilateral would be a better name if all three sides match. Okay, so equal angular could be also acute, another name for it. On the back, we're going to name our shapes, our triangles. They're all triangles, so we're not going to include the word triangle. So we're saying, okay, what kind of triangle is this? Well, this right here is an isosceles triangle. An isosceles right triangle. Why? Because it has two of the sides the same, and because it has a right angle, it's an isosceles right triangle. And so the next one would be a scalene based on the sides. And it's also obtuse because one of your angles is going to be greater than 90. So it's obtuse. And that's going to be a triangle as well. So a scalene obtuse triangle. The third one is equilateral. Okay, you could call it isosceles, but a better choice would be equilateral. Okay, and it's equal angular. Okay, and we could call it acute as well. Okay, and then the last one is scalene, and it's going to be right. Okay, scalene right triangle, because none of the sides match and it has a right angle. So by sides is scalene, by angles it's going to be right. Moving smoothly ahead, if you look at a picture that says, hey, find the measure of x. Well, what kind of a triangle do you have? Well, we have an obtuse because of the angle. We also have an isosceles because these two sides match. Well, if it's isosceles and those two sides match, well, then that means that JH is congruent to HI, okay? And by the definition of congruent segments, if the segments are congruent, their measures, their lengths are equal. And so you could say 5x plus 4 is equal to 2x plus 16. Solve it by minusing 2x from both sides. You get 3x plus 4 is equal to 16 plus 4 to both sides. You're going to get 3x is equal to, or minus 4 is going to equal 12. So x is equal to 4. And if you plug that in to the JI, you're going to do 4 times 4 and subtract 10. So that's going to be 16 subtract 10 is going to be 6 inches, okay? Or units in this case, sorry. So write an equation that talks about what's true. It's isosceles, so their measures are equal, and then you can solve it. Naming triangles. There are 3 triangles that are shown here. The first one is going to be, if we do this right here, let's call that ABC. And notice all the sides are equal, so we're going to call it equilateral. And all the angles are congruent, so that would be equal angular. You could also call it acute. But the best would be equilateral and equal angular. The following one would be, let's go right here. Okay, so that would be ACD. ACD, and that triangle is going to be, look at this angle. Since this is a linear pair, that's 120 degrees. So that's to be obtuse, and it's going to be scalene. Okay, and the last one is comprised of the entire shape itself. Okay, so ABD. ABD. How would you name that? It's going to be scalene. Okay, I guess we looked at that second, but it's also going to be acute. So acute and scalene would be the 2 words I would talk about. Okay, so, and it's a triangle still, obviously. The last one we're going to talk about would be to find the lengths of the sides so you can classify it. So we're going to use the distance formula to find the distance between any 2 points. We're going to use the distance formula, which says distance equals, and you minus the 2 x's and square it. You minus the 2 y's and you square it. You plus them together and you take their square root. So if you want to find the distance between any of these 3 points, you're going to use the distance formula. So we will take k, which is -2, -6. -2, -6, that's k. And then -4, 0, that's p. And then 3, -1, which is going to be L. And so if you want to classify it, it kind of looks like it's equilateral, but you can't just go by looks. You should actually figure out the numerical distance between those. So pick 2 points, let's find the distance. So if you say, okay, let's find the distance from K to L. Well, of K to L, okay, we're going to take the 2 x values and we're going to subtract them. We're going to take the 2 y values and we're going to subtract those, and then we're going to square each and then add them up and then take their square root. So the difference between the 2 x's is going to be -2 subtract 3 squared. The difference between the 2 y's is -6 subtract a -1 and then squared. So that's -5 who gets squared. And that's going to make a positive. So it's -5 who gets squared. That's 25 plus 25. That makes a square root of 50, which is going to be in decimal form. Let's take out my calc. Square root of 50 is about 7.07. If you break down the radical, it's 25 times 2, or 5 squared root of 2 units. So that's a distance from K to L is about 7, okay? So to find the distance between another 2 points, well, then you're going to say like KP or PK. You're going to subtract the 2 x's. So the x here is -4 and -2. So -4, subtract a -2 squared. Subtract the 2 y's, which are going to be 0 and -6. So 0 minus a -6 squared. This will make -2 who gets squared. This will make 6 who gets squared. That's 4 plus 36. The square root of 40 is about 6.32. And the breakdown of that is 4 and 10, or 2 squared root of 10 units. Okay, so those are going to be the distance from P to K. Well, so it's obviously not equilateral. And so what we want to do then is to find out the distance from the last distance, which would be here from P to L. So to go from P to L, you're going to subtract the 2 x's, which is going to be 3 and -4. So -4 minus 3 squared. Subtract the 2 x's, which is 0, subtract a -1, and then square it. And you're going to get -7 who gets squared. You're going to get 1 who is squared. You get 49 plus 1. The square root of 50, we did that up here. It's 7.07, and you get 5 radical 2. So the truth is, if these 2 distances match, it's isosceles. So 2 of the 3 sides are congruent, so therefore you have an isosceles triangle. Okay, there you go. Have a good day.